We are there recording. Recording as well. Please. Yukoko, we are on live stream. Today is the 30th of March 2014. Yukoko is in Fukushima. We have seen. Can you show us the document regarding the soil in the gutter, please, with 30,000 contamination? This is the soil from the rain gutter taken on the 28th of the 3rd of 2014. Shows 32,410 becquerel, 134, 137, 83,000. We have added the nanomaterial to it, and it's going to be tested. It's on a dry basis, so it's direct application to the soil. This is 3 years after the Fukushima accident. Thank you very much, Yukoko. Thank you. Now we are testing the water in the bottle. Is the water from the fire station in Fukushima city itself, taken 7 days ago. The contamination level, can we have the paper if you have it there for us, Yukoko, please? This comes from the water reserve tank in the fire station in Fukushima city.
Now we measuring again, but only this clear part.
Yes,
But
this is okay. It's 51.8 becquerel, 134, 137 is 132. This sample was taken 7 days ago from fire station water reserve tank. So we have, this is including the sediment. The water now is getting tested without the sediment, and we are washing some more. This is the water with the sediment residual. The water has been separated now to test it on its own. We are adding some more water to what is left of it's been collected to create more clear water. This time we just want to see the effect on the clear water situation. So you need to open the big bottle, Yukoko. Open the big bottle, put water in it and shake it very well. Put pure water in it. Yeah, just use a sieve and put water in the big bottle, the cola bottle. Yeah, in the water bottle.
Mr. Keshe, the people from Fukushima suggest me to adding this water into here to make it more sample. Do you think it's
It doesn't make any difference. You need to do it the reverse. Put water in the bottle. And just put water in the bottle and shake it. Then you wash whatever is in the sediment. It doesn't matter. Go. Go up to. That's enough. Stop. Now close the bottle. Close the bottle. And shake it well. Just let it wash whatever is in it. Shake it well. Okay, should be. Let it settle. Now let it settle and see whatever water we get. Pardon?
So we waiting for this to be sink.
Yeah.
Settle, yes.
Yeah.
And then now I move this clear part.
Yeah, then you add them together. That's perfect. Yeah, add it with the water which you collect from the bottle. Because today we don't want to see sediments or soil. We literally want just clear water. 2000, 3 years after, in the gutters of the rain, in the house.
Normal.
This is from the house of the guy where he lives. In Fukushima City. That's good.
So it's not enough. So
I think, Yukoko, if you empty the big bottle into this container where you're holding, the settlement will be much faster. Okay, put it down. Just empty that bottle in there, please. No. Oh yeah, okay, take that as well. Whatever you have, just take.
I treated it a little bit, so I have
It's
to
okay.
wait.
No, you know this big bottle, you just put water in?
Yeah.
Empty it in the container with the plastic in it. Next door. No, the other one. No. The big bottle, you just put water in.
Yeah.
This bottle. No.
This one.
No, number 4. The bottle number 4. Yeah.
Number 4.
Yeah.
Yeah.
Empty that in the one which is just on your right hand side. Let it settle faster.
You mean it's sitting fast
No, the
here?
other one, the other container. Left hand side. No, Yukoko. Yeah, that's the one you got. Both of them are in your hands. Both of them. Oh. Yes, that's it. Empty the bottle in there. It settles faster.
Okay.
That's enough. Yeah. The containers today are smaller than yesterday. Yesterday they had a 1.5 liter. This looks like a half a liter. We just gotta wait. Till it settles. My heart goes with these people. How they're gonna walk out of life without any problem, I don't see. The radiation is going to 128. It went to 141, it came to 128, so it's steady. She's going tomorrow back to the same place to put copper oxide in the dry powder. You know, there was a pack of dry soil in there. We have already put some copper oxide into the soil from the gutter without any washing. So we see if the reduction comes through what they call it, destruction or conversion of the cesium into anything else which is non-radioactive, stable condition, or there is a possibility the copper oxide, because of its combination, is absorbing on its own all the radiation, and it shows a conversion. Can you put the heating on? Are you warm? So this test completes a lot of things today. Now we should be able to understand ourselves in the properties of the CO2, because we see the copper in a wash condition. Now with this process we eliminate the process of the filter which they used yesterday, because using the wire filter we were at 225. We used copper oxide, we went to 85. We mixed the two together from the water with the boat, we came to 128 now, but more or less the same amount of liquid. and the I think the wire mesh is not the answer.
And because that didn't seem to change. It changed, came from the copper.
No, we came from 414
Yes.
to 20, what do you call it, to 225. When we split it.
Yes.
But the same half, applying the copper oxide directly to it, it came down to 85. Now it's sitting at 128. Now this should show us the difference between the copper oxide direct and wire mesh. This next water which is extracting, and we're going to use part of it for CO2 and part of it for the wire.
Yes. For the copper oxide.
We already have a container, it's going to be measured for copper oxide.
Yes.
So now you're extracting more clear water.
And the CO2 is that's the CO2 you gave.
Yeah, that CO2 has a property. Maybe the copper oxide will, if it doesn't gel but reduces the containment. Yeah. Pardon? It is absorbing radiation, converting the cesium into non-radioactive property material. We got to speak to 2-3 different agencies and see that all these materials can be dispatched immediately to be tested around the world. Maybe we send one batch to Geneva to international energy authorities. Somebody has to go to Geneva with it, maybe if, or we send one to. It's got to be tested by 3 different independent institutes around the world, that we get a firm, what do you call it? Confirmation. Because if it's correct, then the situation with Fukushima can be resolved. We can recycle it the second time. The same water which is at 128, tomorrow if she goes back, we take half of it and we put it through the same process, see if it reduces to lower levels. Huh? And if it goes to lower level, we can reduce it by another 60%. Within 3 processes, the situation is resolved. Yeah. Then it means the ratio of the material of what we produce has an effect on the radiation conversion. So if we have to increase the process or repeat the process. So if you increase the CO2 amount into the liquid.
And does the same material can be reused?
Yeah, what I think the material, the nanomaterial, according to our research on what do you call agriculture, can stay in the ground because it becomes a fertilizer. And because it's in the ground, it can permanently, whatever radiation gets washed in or rained in, to dissolve itself. Huh? But what is the Marek, can you see what is the hazards of overdose of copper in the human body? Is there any report on Wikipedia?
There is toxicity.
Yes, but this is in the gans, it's not in the matter state. Yeah, digestion, what's an overdose of copper? Because it's in the gans, this is an energy level, not in the matter. But if, let's say, in the body converts to matter, what's going to do? This is an unknown factor. or through this process we can grow materials which are radiation resistant.
What is known is the effect of copper. That is
Yes, but if the copper stays within the material and it stays within the soil and becomes a fertilizer, the way we've seen it with the agriculture test in Belgium, then it becomes a process that it actually any new radiation gets decontaminated before it's absorbed by the seed. That's the reality. Yukoko? Hello? She left us, she's gone. Hello, yes. Do you have any clear water there now?
Yes, getting.
Okay,
Yeah.
just try to empty it and see how far we go. You see
But
that?
still have a lot of weeds inside. I try.
Yeah, because the radiation level in this thing is... I think we have enough.
I think so. Yes.
Okay, let's measure this one and then you split it in two halves. Okay?
Mhm.
Measure this one and then we split it in two halves and then I'll tell you what to do with the halves.
So I send it to the measurement
Yeah,
now.
just send a measure. Write on all these papers what is happening. Is the soil being measured yet?
So it's under measurement.
Is it-
Under process now. It takes
Okay.
another 15 minutes. It takes 30 minutes for measurement
Yeah.
in this
System.
system today.
Yeah.
And because it's a very small amount of the sample, so it takes more time than yesterday. Yesterday we have a large, like a 1 liter container for the measurement.
It's a small radiation detector. There is a water to be measured. Has that water been measured yet?
I think it's also still in the process.
If
Sorry
it
for
hasn't
waiting.
gone, Yukoko, if it hasn't gone into the machine to be measured, mix the two clear water together, then you have a good contamination level.
Yes, okay.
Okay, if they haven't measured the first water yet, mix that one and with the one you just made together, then we have 3 samples to work with.
Okay.
Just let it settle. If we can get more water for the next test, it should be good.
I will move to this space now.
Yeah, we'll move it somewhere else out of the way.
Yeah.
Just let's see if we can get. Try to get more water into it that it can get more residual from the bottle. No, the other bottle, the number 4 bottle. Empty more from the bottle 4 into that. Yeah. Yes. Empty more into there. That you get more clear water.
they don't see any evidence of, let's say, cancer caused by
Cancer.
copper oxides. They don't see evidence.
Evidence, okay.
Only copper sulfate.
No. Empty the bottle number 4 into the big one. Try to get all the water out which is clear. Yeah, yeah, okay. No, 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 it's shaking. It's okay. Jesus. Go all the way to the top. Go, 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 go all the way to the top. Okay, that's enough. That's enough. That's enough. We got. Oh, okay. Enough concerns. Just if we need water, we can carry on using it. If we the process yesterday, that the CO2 is the most effective way to do it. Then we're going to now make a comparison between CO2 and copper oxide. But I think copper oxide will be more effective because it's got a higher gravitational field. Yukoko? Yukoko? Can you hear me? If you can get the authorization from the Japanese authorities to ship part of the samples of yesterday and today, depending on the result, especially yesterday, to International Atomic Energy Authorities in Geneva. Okay. They can send it to the Iranian delegation in International Atomic Energy Authorities in Geneva. I take the responsibility on behalf of Iranian government. You ask them, it has to be received by the Iranian delegation. Or if they don't want to do it, they can do it through the Japanese delegation. I speak to the Iranian authorities to accept this in Geneva and get it tested in Geneva. Okay, so you got to see if the Japanese government allows us to ship this to IAEA to be tested independently in Geneva, and they can keep part of the sample in Tokyo to test in TEPCO. Because the result you achieved yesterday, it is very, very crucial and critical. Yeah, it's a major breakthrough. Tomorrow, when you go back, you have the material which is 128. What you do, you take half of it and you add another part CO2 and another part copper oxide to it. We see if the radiation level goes lower than 128 again. Then it shows maybe 2-3 processes can be done. We got to follow this through tomorrow. Speak with the guy in the first lab. Speak to the guy in the first lab yesterday and tell them we need to do a further examination. We have more copper oxide here to ship.
Okay, I think we have a sample of 1.3 kilogram. So
where?
I mean, yesterday, from yesterday, the one you just mentioned.
Yeah.
So it's 1.3 kilogram sample. It's been continuing measurement today and also tomorrow. And then as soon as we finish this measurement, let me confirm that the way I should do. I shall separate it. This half of
you
this.
half it. Measure each half for contamination.
Okay,
and then measure, and then one half you add again another measurement of copper oxide,
Okay.
to see if the radiation reduces again by applying the second time.
Okay.
And again, another part of it, you add CO2, a small amount of CO2 to it to see if it measures. But keep half at 128. The 128 you need to keep all the time as a sample case. Yeah?
Okay.
Because we have the original soil with the 1,400 or is it 1,140 contamination yesterday.
Yeah.
Yeah.
Sorry.
This is this we want to know if the repetition reduces the radiation, or maybe later on we increase the CO2 in the process. The one thing which is important with the guy who you were yesterday, you asked them after the test that to use part of the liquid which is there with the soil in it in a field to grow rice, because I saw a lot of rice on the table in that lab. They're testing local rice. We want them to grow rice with that whatever you leave them. Maybe the rice, we know the rice will grow drastically in a different way, will increase the harvest by 6 to 10 fold. But we want to know if the harvest will be radiation resistant. You understand? It's because the contamination will follow in Fukushima. It's not going to stop, but maybe the soil or the nanomaterial within the soil which the seed grows in will absorb any future contamination, which is the farmers can farm without any problem in the future for the time being. But the process is but it's going to be permanent. There is no difference. It's okay. Just ask them, they can use half of the package, whatever you leave them on the second process or the first process, to run trial on seeds. That it is very highly possible that the seed will not, will not show any sign of contamination any further. But we've got to see, because we don't test in Belgium for the growth of the seeds, but we never done tests for contamination absorption. We've got to learn this. And there are the seeds, I saw a lot of rice there, we've got to see the result. Is there any result coming up?
Let me check.
We are in uncharted territories. Don't know where. It's very interesting because now live stream, everybody learning exactly what we're learning at the same time. This process has caused a lot of problem with a lot of doctors and professors. No, what does that say? No secret meetings in the background and chat. We have it. Can we go and patent it now? We discovered something new. Nobody knows. It's on the line. People read it. People do it. But what is shocking me is the contamination. It's in the gutters of the guy's house 3 years after. Yesterday, in the soil which they got from the land, we only saw 1,100. This guy's in his house is 32,000.
Yeah, because that's the air, and what is
Which
in
is
that
raining.
is what has been raining. So you don't have the soil. You
This
just have to watch stuff.
this shows a huge cover up by by the Japanese government. If in one house in Fukushima 137 is at 85,000, how many tons have been released? And this is a small gutter.
Yes, but that's the surface of the roof.
Yeah, but how many roofs? That's one roof.
Yes.
And this is one part of a small piece. It's not even half a kilo. Huh? How much? It's how many years it'll take to get dirty. Can you go on the internet and check the Japanese government for limit or international limit for becquerel of cesium 134 and 137, please? If you want any tea, the cups I think are downstairs. Then bring it up. It's fresh. That water is settling in there.
Even says that yesterday when microphone was
Yes, he told me. We are open, we have nothing to hide. We don't talk about naughty things. It's good. Issues are openness. We are not afraid of, or don't lose sleep if you are doing something stupid here. But this is when you do things correct, you have no fear. Unless we talked about something very nasty, which we did. I bought this that we can give this back to. What does it say? Pardon?
for limits on radioactive cesium in food. 100 becquerels. General food stuff 500.
How much?
500 becquerels limit.
Limit, maximum
Yes.
per year.
And in European Union is 1,250. So the limit in Japan is half.
Yes, but it was the new limit is 100. This one.
Come on, guys, make your mind what you're doing. This is your new microphone. Okay, so let me see. Can I move in? Domestic origin of radioactive cesium in food.
This was
Japan. Drinking water has to be 200. In general food studies, food items for babies.
this blue is
New limits,
I don't know.
it's 50. European Union, United States 1,200. Put everything as 1,200. Babies 400. Correct. So but it doesn't say what measurement.
It says only that it's in unit becquerels per kilogram, but
becquerels per kilogram. So yesterday 1140 is 7 times, yeah, in the drinking water. General food, we don't have a food, so that is there. This guy's house is contaminated by 160 times more, yeah, and even by the American standard is 25 times more in 134. Does it give you cesium? Which cesium? 134 or 137?
They say just
Cesium.
just cesium, but they are not specific. Radioactive cesium is
It's 1,000 macro. There, look, go. Here it says the Codex highest permissible level of the radioactive cesium for general foodstuffs is 1,000 becquerel per kilogram, or 10 times the level now proposed by the Health Ministry.
and they propose 100 here in the blue.
And now you go to 85,000. It is 840 times more.
That's propaganda, this law, because
Huh?
this is propaganda because these limits are not real.
Yeah, but this is 200 is a maximum limit, yeah? You got to look at about 2025 as a normal. 10% of the maximum. If you're going to get the maximum dosage every day, all the time, a year, you're dead. So the guy's gutter is it's very clean. Because when you're dead, you don't have any problem. 840. No, yeah, it is 840 times more. Even at 100 becquerel. That is the dosage of, let's say, nearly 3,000 people in one roof, in one part of a small roof, just in the gutter. You can kill 10,000 people with one spoonful. Invite people for a soup. No, you can decontaminate people, huh? If you get an overdose, it's like getting a bleached. This is crazy. This is not a joke, this is crazy, because if it's on a small roof, in a small gutter of a one roof in Fukushima, and this is this level, how much is in the whole of Fukushima?
In the food,
An interesting figure might be the surface of the roof.
Yeah, but the surface of a roof, let's say, is 60 square meter.
Yes, but
Yeah?
something that we should ask.
Yeah, okay, we're gonna ask 60 square meter. 60 square meter, let's say it's let's say 10 by 6, a Japanese house. Then you have two sides, it's 3 meters, and this is from 10 centimeters of the 3 meters. It's just taken from its gutter. Huh? So it's from maybe half a square meter.
Soil from the roof.
It's a soil from the gutters, you know, where the roof, and then you clean up. It's picked up from his gutter last week, and this is 3 weeks after, 3 years after. It is huge. Yeah. The farmers are told you can farm, there is no problem, but the farmer they were interviewing on NHK, he says, I don't eat my own food, how can I sell it to the other people? But they say sell it, it gets mixed up in the national average, then it gets mixed up. It gets mixed, there'll be less. You're unlucky by chance, you get one, what do you call it? Yeah, one cupful from a contaminated area, that's it. You're done. It is crazy. But we have no choice, you can't blame nobody. It's accident. That's what it's called, an accident. Yes, the chief inspector is coming back. Hi.
Hello, hi. The result is now on printing, but we could see that almost 10% reduction.
Okay, no. How far is it left to go? Is it completed?
Yeah, no, it's still on printing because he calculating.
Can we just look at the figures? Can we look at, this is the soil one, yeah? Or is it the water?
Yeah. This.
Okay, let me look at the results, please, of the soil.
Could
in
you wait a
writing.
few minutes?
That should be about 29,085. 79. 10%. Don't know about history. Don't know about biology. How many people are on live stream?
It was not announced, so 28.
It's like the other workshop. We're talking and somebody fell asleep. We could hear him snoring. And Rick was trying to find out who's fallen asleep. We need data, we need figures, then we know where we are. Maybe this is a good time to add the second half of copper to the same sample immediately if we see we get a reduction.
Does any reduction already sees up? Comes up or no?
Yeah, she says 10%.
10%.
So if we add second lot, which is got on the floor, to the same amount and see, then it gives us a ratio.
Double,
Yeah, let's see.
That was done without adding water.
No, just straight from the bottle.
Or just the water.
The copper water, no problem. Oh boy, so you gotta go back in there and start making new cow. You gotta milk as much as you can. But you can set a process up that it goes much faster. So if it's positive, we what do you call it? We gotta forget about our brain system, all that material. This is how your reaction is going to be. People coming out, well, nothing is happening. Oh, look, it's moving. And they call, look, it's flying. Half of people are all on there. Look, who is flying.
It's not so much action.
That's how it's going to be. So boring. People come and go. I think we have to put one of these TikTok, in the background that is a live program. It's not, it's not a picture. Something has got to move in the background. It's a good idea, in our lab we got to do that. We have to put something in the background that people can see. This is not a picture, it's just... Or a mouse in a box which just goes on these rollers, spin wheels. Oh, look, the mouse is dead. Or it'll be fantastic if we can get a bunch of these, what do you call it, keep fit people in the background. Next one is live. We get a lot of people watching us. I had a email from Dave this morning, or yesterday morning. It says I gave a talk to Mike Harris last 2 weeks ago. Says, I don't know where they come these numbers, but it says last week was 3 million audience, and the one I did on Friday, he sent me an email because they use it for advertising costs or whatever they charge. It says it was 4.2 million. I said, now we're gonna go start charging, huh? Funny thing is, this liquid there in front of us is coming from the fire station tank in Fukushima. So they go to help people in trying to put the fire out. They contaminate them, capsule more. That's coming from the station. Even by the American standard, this what the test is coming out is 84,000. It's 840 times more than normal by the American standard. And if you multiply it by 5, it's 4,000 times more contaminated than the international maximum level in Japan. When you divide it by 2, it's another 8,000. And this is from, the guy said, how long? 60 kilometers from the station.
It was yesterday.
He's taken this 2 days ago from his roof.
But it's the same place.
Yeah, it's I think so. That's what this is. We gotta ask, locate it. You Coco, can you hear us? Can you ask the guy how far he lives from the station where he took the sample from his roof, please? Armin is asleep. You're gonna bring one of these hammocks for him, huh? I can't hear you. Can you repeat again?
Yeah, I just asked to the guide. This is the soil. I mean, from the rain. How to say?
The gutter. The gutter.
Yeah, rain. Yeah. He's living in 60 kilometers away from the Fukushima power
And
plant.
60 kilometers from Fukushima, the plant or the city.
City. Yeah, still inside of the city, Fukushima city.
He lives in Fukushima city, 60 kilometers from the plant.
Yes.
Yes. And the radiation 3 years later is 32,134 cesium and 85,000. Okay. Have you got a new reading yet for this?
Yes, now it's calculating.
Now it's calculating. Okay, thank you. That's 60 kilometers away in the city, Fukushima city. Yeah, it's there, 134 and 137. They are not giving us, they don't have a reading. Strange enough, we can't get plutonium measurement. I want to see what is the plutonium. Somebody has to give us the data for plutonium in this contamination somewhere. Or we've got to bring a part out and test it. It has to be done. It has to. This is data is clear. Huh?
International problems.
You got to put the clock back by 1 hour, or is it correct? It's corrected. So, what's the time? The new time. Quarter to 5, is it now?
That's yesterday's time.
Yeah, but are we going backward or forwards?
Forward.
Backwards.
Forward. We have to.
Pick it up. Turn it on its back. It's amazing. Such a big thing has got such a little brain. I think the way these slots are going, we're going to be here for lunchtime.
Yes, we lost 1 hour of sleep.
Who's going to pay us for 1 hour of sleep? I think we're going to do this tomorrow morning as well with Tokyo, with Fukushima. Actually, we don't need to do it, but we need a dry soil. Dry soil is more important than the wet soil, because it shows direct. Well, we didn't give it up. Would anybody like to fly to Fukushima with some of the copper oxide?
Need a passport?
We don't need a visa.
Yes, but I need a passport.
You don't have a passport.
They also
How?
don't have passport.
International passports. He has.
International passport.
I have all one.
Passport is in Belgium.
Belgium. Well, you go. You travel with your ID. Like, yeah. You have your passport with you, so you're the only candidate. Shall we send our
Share with this guy.
or shall we send our American delegation? We are attach to a radiation detector. It goes beep, 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 go back, we're going back. I don't know. Marek, can you just go and give a chart of the plutonium nuclear decay? See what we get out of it. On all its isotopes. Just use Wikipedia. Okay. Just look at this decay. Yeah, but what does it decay to? Just put on the top what does plutonium decay to.
Okay. Okay, Mr. Keshe.
Yes.
Okay, let me explain the situation now.
Yeah.
This one was the original.
Yeah.
Yeah, so now what
32,000 and 83,000.
So what they're trying to do is they recalculate it because its container is have a 93.0 gram, and then we adding the water this amount, which is mean 25 milliliter almost.
Yeah.
So it's changed the volume, so that's why they're trying to calculate it.
Okay, what is the result now?
Okay, this is the result. Initial result was so the original was this, and they calculated that the first measurement.
Wow.
Like this. Wow. 30. No. This is not the result. This is the first one. They recalculated. Depends on the the volume of the sample. This one is the equal to this in the volume.
Okay.
I mean the 90.
Now they're converting.
Yeah. Then now 3014.
Yeah.
And then it became 2000.
We need the exact matching figures.
Yeah, those two are the differences. Can you see? So this is the initial one, 3000.
Can we
So
have without the weight on the other becquerel per kilogram? Can you give us one without, compared to the 32,000? No, not this one.
Yeah, the original.
We want original. We want to know what is this without conversion. I want a copy of that measurement.
Okay. They're going to.
Yeah, I want that measurement. Yeah, please.
Okay. So, but I can see that more or less 10% reduction.
Yeah.
Only just mixing.
Yes.
It's usually the soil is very, very attracted cesium is very attracted to this kind of clay, like soil, clay texture. It's very attached to the cesium, but we could see that only that adding this nanocopper mixing, and we could see the 10% reduction immediately.
Yes,
this
but
is
what
the
I'm interested in, forget about, because they're trying to do adjustment figures, which is not correct to me. I want to know the exact copy as that 32,000, we just without calculating.
Yeah, okay.
Yeah, that's
now
what is counting. I want to know the radiation count as it is. It's not even 10 milligram. Should not be. We just want to know the real condition figure on it. Alright, calculating, assuming. So this is a calculated, not measured. We want the measured one. Then we know what we have in our hand. Forget about.
Not so much quantity.
No quantity. No.
The sample is not very big.
Yeah.
So this quantity will
Well, it's irrelevant. Very relevant. Very relevant. Totally relevant. I tell you the reason for it. Just go decay. What does it decay to? Beta decay to what? No, plutonium decay. Americium, there it is. $41 goes to 40. Plutonium.
Okay, thank you for waiting. Here is the result.
Okay, we want to see the results. Okay, what is it? This is exactly, okay, put it next to each other, please. Put the other one. Original one was 32,000, not your 25. 83 to 65. This is, okay, what I want you to do now, get the sample back, please, and add the rest of that bottle into your container. The soil, yeah? Get the soil, please. That is from 85 to 63. Or 83 to 65. That's 20% discount. 20, 30%, okay. Because it goes per kilogram. So, and that one is come down, was it 25? From 32. That's under 20%.
Depends on the quantity you put.
That's what I want. No,
That's
no.
what
What is interesting? I
Okay.
explained to you in a
So
minute.
here is sample 1.
Okay. Add the rest of, this is the one you already put copper oxide in, yeah?
Yeah.
Add the rest of the copper oxide into it, mix it, and get it tested again, please.
Okay.
Okay, I'll tell you why. This shows clearly that the copper oxide is converting radioactive materials to non-radioactive materials, absorbing neutrons.
Mm-hmm.
Because we haven't washed, we haven't done anything to it. It's just by applying. So what this means, we don't even need to wash. This is one of the major breakthrough with this thing. What I want you to do, get rid of that water which is on top of this small bottle, most of it. Get rid of the water. Yeah, with the syringe. You're well trained. The doctor.
Okay.
Okay, extract that water. Throw it no, you cocoa.
Yeah.
When you extract it, throw it away. Don't put it anywhere.
Yeah. Okay.
Okay, don't put it anywhere. Just put whatever is in the syringe. Put it down the chute somewhere.
Mm-hmm.
Okay.
Let me put the empty container.
Yeah, get the empty container. This shows we don't need even to wash it, to separate it. This saves a lot of money for holding the contaminated material, because by itself
Will it decrease in time?
it shows the results from yesterday. It's to 128, because even 141 came 128. So what it really means, you don't need to hold any material. You have no contaminated material to hold, because by itself it becomes non-radioactive.
最初のやつをしたので、この部分に水を
In the secondary problem of the copper being added.
There is no copper in there. I don't think so. This is the problem. This is what I want to find out. We'll find out very soon. Get rid of most of this water. Yep. As much as you can. But enough that you can get rid of the copper, get the copper out. Yeah, okay. Shake the rest. Shake the rest very well. Yeah, shake it in the... No. Don't go any further. Shake it very well and add it to the soil number 1 again and see if the measurement goes down.
Mm-hmm.
Okay? Where is the other one you had with your spoon? Open the sample which you just measured.
Mm-hmm.
Yeah? And
Let
mix
me
this.
measure this amount because they need to calculate it, the mass, the volume of the total sample. So let me calculate the volume.
Okay, keep that. We are not interested in that.
Right.
We are not interested. They don't understand what we're trying to do. Okay, no problem. Let them measure whatever they want to measure. Volume.
Mm-hmm.
Oh boy, you haven't got a clue what is hitting you.
また計算いただけるよ。そうです。はい。今日はどれぐらいまた減るか。またお水の量を。
If you make it more concentrated, so you should be able to do a better job. Yukoko, can we have a look at this sample? The one in your hand. This is the one we already put copper oxide in, yeah?
Yeah.
Open it.
So,
Let's have a look at the physical structure. Open it. Don't hold it in your hand so much. It's radioactive, darling. Just open it. Let's have a look at it. Go back. We don't see. We just see the top of your hand. We can't see the container. Just hold it towards me. Just leave it open and just hold it towards me and the camera more. Do you see any changes in the color or texture? Do you see anything? Don't bring it so close. You don't see no difference.
No difference, yeah.
So,
No orange.
do you see
Like
any of the
yesterday?
blue residual from the copper oxide?
No.
No.
It's totally absorbed, I think.
Okay, mix the other
But
one into it.
Can you see?
On the bottom.
It's on the bottom.
Yeah, in the bottom, maybe.
Try to
Yeah.
try to mix it very well.
Okay.
Okay.
Yeah.
Okay. Try to mix all of it with the other one. Yeah.
Please let me
Then measure
just
it. Measure it if they're happy. No problem.
はい。
70cc という容積に対して、
はい。
どのぐらいの重さがあるのかというもので、この
Can I ask you a question? Just
Okay, please wait. The guy is 座っていただいていいですか
What was the mass on the... Ask him, what's the mass in that pot? What's the weight of the pot?
Okay, that's it he's asking. ここの今質量がいくつですか
容積が 70cc に対して、
はい
70cc までこう、
cc by goes by weight kilogram by.
はい、重さはどのぐらいあるのかっていうことで質量の計算を出していて、
はい
もうすでに 70cc をオーバーしているので、
はい
そこにさらにそれ追加していくと、どんどんこう正確さがこう離れていきます。ゲルマニウムハンドタゲンスキの方がその 70cc 用の設定になっているので、
はい。Okay, what he concerned, let me explain, Mr. Keshe.
Yes,
Mr.
I'm listening.
Keshe?
Yes.
Okay, so what he concerned is because of the accurate measurement,
Yeah.
it is the special container for the measurement system, which is 70cc in total.
Yeah, but how much does it weigh?
It have to be full up. So 70 weight was これは今 109.1 だったんですよね。要は 93.0g だったのが今 109.1g になったということですね。So previously it was 93g.
And how much is...
We add this nano copper and it become 109.1. So it's 7g. We added.
Okay, now add the rest to it.
But he just concerned about that if we include in the mass because of the, can we remove a part of the soil?
Yeah, a small amount. Just take a little bit out. There's no problem. I don't think... how much do you think now it will...
これを要は加えて、さらに Hello? Sorry, I asked him because yeah, I can hear you. Because the guys are really concerning about the accuracy of the measurement. So he's suggesting us the some methods. So please, sorry, if you can.
What do
they do?
Let me see. Let me explain. これが
まあ、同じようなところから取ってきた、前に実験に使ってた。
じゃあ、同じようなところだけれども違う土を使った方が、要は、
ここに付け足していくとどんどん質量変わっちゃってダメだよね。もう
この
70cc
土
を
を
オーバーし
除いて
て
もダメですか、正確に。
除くんだったらそのままやった方がまだいいかもしれない。
そうですか。そういう形で、なるべくこの水をなくした状態で今回足していって、で正確にこれで測ってどれぐらい追加したかっていうのをやっていくんです。
ちょっと
でもやらせてとかはい。I can see the, okay. 多分ですね、実験のポイントとして、but I need to measure it first, so please let me measure. Thank you. Thank you. So, I'm going to put inside. Okay. わかりますね。じゃあ、これで、レベルで、この25分ずつをよく、あ、うんうんうん Uh-huh. Okay. Yeah. Mm-hmm. Got an empty. Yeah, I do. I do. Okay. Empty. Wait. Okay. Mm-hmm. Okay. 今、ちょっとこれの、要は中のグラム数で、
ここに向かって総量で測ればいくら
そうですね。はい。Okay, they already measured this container, so they can know that the amount of this. Yeah. Okay. Thank you. Mhm. Sorry. So you mean this? Okay, I need something to stare again. すみません、混ぜるもの。I don't, I don't want to. Just okay, yeah.
This looks like the blue. H. You know what to do.
さっきのないですか？さっきの。すいません。出ちゃった。I think it's really Japanese things to eating sweets. で、なんか小さいみたいなやつですよね。お菓子用とか。Okay. そうですね。ああ、そうなんですね。いや。Yes, it's the best things in Japan. Mhm, mhm. Water, yes, it's already done. Now I'm waiting for the paper result. Mm-hmm. 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 Okay, please let me finish this first, and then I will back to you. Okay, so here's the result of the water. Here is the result of the water, the clear water. Clear, contaminated water. Okay. There's not much, but it's 20, 30 in total. But this is the radiation level of the tap water in Fukushima now. So we can probably make a solution for that. Yeah, it could be in a partial evacuation area has this amount of water contamination in tap water. I mean drinking water. So it's going to be very big hope if you can find a solution. Yeah, yeah. Mm-hmm. Mm-hmm. Stamp, proper stamp for the okay, certified. Yeah, certified. Very Japanese. Yes. あ、これか。はい。This one.
Okay.
Yeah. Mm-hmm. Okay. Mm-hmm. Mm-hmm. Okay. Mm-hmm. Okay. Mm-hmm. Okay. So divided to the three. So I need a smaller container for the measurement. あ、これ500ミリリッターなんですけど、この小さいサイズの容器、はい、これが一番小さい。70cc。これです。あ、これですか。これを3つってあります。あ、ありがとうございます。Okay, they have this 70cc container.
Important thing is you are extracting a new material. The new material is producing
Okay, now we have 3 containers. Over 2 more groups.
coming back.
Yeah. Now, could you repeat it again? Hmm? Okay, okay, I will ask. But I think it's exactly the same as here. So we just simply move. Yeah. And it takes each 30 minutes. So I think it's too much. Yeah, yeah, okay. Yeah. Okay. Yeah. Thank you for understanding the situation. Thank you. すいません、安部さん。今この水を全部それぞれ入れさせていただいてるんですけど、ここからただシンプルに抽出してるので、同じ。
いや、おそらくそこの方に沈んでると思うので、もし、ざっくりやるんだったら一回戻してもらって、吸ってる状態で中の沈み物が待ってるような状態でやれば。
Okay. So he suggests us, he said he doesn't need to measure it again, but there is a sediment bottom of this. It may affect, so I need to get the sample out to shake, mix well, and then, yeah, so let me do it again from the, yeah. Okay. They are very professional. So yeah. So now I shake. Thank you. Mhm. 振ってすごく早く今水を取ってますね。Okay. So, yeah, I have to be in the line precisely. Okay, that's it. Thank you. Okay. Mm-hmm. Here is, do you want to use this? Okay. Copper oxide. I have to bring. Yeah. Mm-hmm. Yeah, I understand. Oh, that's hard. Yeah? Okay. Until the line. So, okay, so the next one is CO2. Yeah. So here is the white CO2. Yeah. Wow. it's a bubbles, little, very little bubbles, like a form like bubbles, and the water texture has changed, like a jelly. It has a little viscosity. Mm-hmm. Okay. So should I leave this? Oh, mm, I found out like okay. So here this cute little spoon. Yeah, it's form. Yeah, form and the gels. Yeah, has a very yeah. It's not very hard, but it's like a gelatin. You know, gelatin. I even see that some kind of this, you know, how to say, it's concentrated. Like, can you see? Yeah. これが放射性物質が凝固して出てきてる。これが福島で多分本当に貯水タンクで起こるべきね。放射性物質を。Okay. Mm-hmm. Okay. This CO2. Mm-hmm. Okay. Mm-hmm. 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 Okay. In. Mm-hmm. Okay. Okay. Mm-hmm. Yeah. Mm-hmm. 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 Let me translate it your words to the people here. すごい今のこの漁港 が、ずっとケシェ博士の、作品を、これこの放射性物質が凝固して沈殿したものが、取り除ければ、多分、放射能汚染、水の問題は、
を移してもらって、
はい。
その分が増える。
この、ここにはい、ありました。今ちょっとこれを、No, Mr. Kesha, here is a suggestion. The people are understanding that this is the highly concentrated cesium or radioactive materials on the CO2. Mm-hmm. Jennifer. Mm-hmm. 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 Oh, yeah. Oh. Mm-hmm. Mm-hmm. Okay, perfect. Okay. Yeah. Yes. Right. Okay. Mm-hmm. 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 So, yes. Okay. But it takes another half an hour. So, should I come back? 残した物体を出して、目だ。Yes. Mm-hmm. Mm-hmm. I have no. Okay. Mm-hmm. Mm-hmm. Like this. And then we're using this just small amount of water. Mm-hmm. Mm-hmm. Oh, そうですか。Okay. So like yesterday, should I go? Mhm. Yeah. Yeah. Leak? No? Oh, no, no, no. Oh, there's a crack in the bottom of the container. Yeah. Oh, sorry. Mhm. But we have we lost some sample on the. We have another water sample here, so we can do it. Yep. This one? Yeah. Yeah. Okay. That's all. Yeah. But I need to move this to the safe container, otherwise I will just spread it out contaminated water on the table. So these move.
使おうとしてるんですよ。これ使おうとしてる。
そうですね。ちょっと一回これを。Yeah. Now it's more safe. Yeah. Yeah. Ah, ですよね。これ何を見たいかというと、その中にもう白濁してつくかどうかを見たいので、はい、水が持つのも構わないんですけど、これを通らせていただく。I try. No. Slightly, yes. It became partially red. Yeah, I mean white, like a very light brown. Let's say it's originally it's very black, but now it became like very. Mhm, mhm. Okay. Oh, yeah. Uh, mhm. The, you want to see inside of the cylinder, yeah? Uh, yeah. Mhm. Okay. じゃあ、ありがとうございます。So now I shake. Yeah. を通さない。
うちは48ベクレル。
あ、そうですか。Oh, there is another water sample even higher. Higher. This one is the one we just finished the measurement. Here, it's also very clear. Can we use this one? Yeah? Okay, I shall keep this one. So here we have also another sample for the next experiment. This is the original. Ah, okay. No, because this is broken, so I cannot use this one. So let me. Yeah, that's why the water is leaking from the bottom. That's, yeah. Okay. So please let me continue like this. Is it okay? Just pause. Ah, okay, okay. 水がちょっと残る程度に。Oh yeah, that's true. I was lazy, sorry. So もう一個同じコンテナがあるので、こっちに変え。Mention. Another one. 下が割れてるのは想定外です。Yeah, from the bottom of this plastic. Ah, no. Now it became negative caption. So now I change the. Do I fit it well? Mm-hmm. Mm-hmm. This one. Celine, Celine, here. Yeah. Mhm. Oh, yeah. Okay. Mm, let me observe. No jellification yet. Mm-mm. But the color has yeah, but it partially become white. Part of the water become white, like a silver, but no gel texture on it. I will show you. No, there is no cracks in this container, so yeah. Okay. Yeah. I'm struggling with my gloves is sticking. Okay, that is okay. So,
You got let's see. For two,
I'm getting there. Okay, so uh, yeah. Should I? Mm, yeah, this is stuck, sticky, really sticky here. So okay. Then this is the measurement. Man. No, I will show it right now after I move to this smaller container. Am I doing wrong or do I? Oh, okay. No solidification, but no, but I could see, but oh no, this is kind of dust. Mhm. No, no whitish. It, I can see some dust, maybe some black. Yeah, things. Mm, just to change mainly. Okay. Yeah, but it's kind of a reflection from the plastic on the table. So let me move to this. But it's no, it doesn't work. White paper.
Yes, just the
Does it help to see the changes? No. Yeah, I can see some settles, like very fragmented powder like materials in the bottom of the container, which is brownish white. Hmm? You mean this small one? Yeah. すいません、この小さい測定用器もう一つあります。すいません。Yeah, seems like. Mm-hmm. Mm-hmm. Yeah, I have. Oh, no, it's empty now. Mm-hmm. Totally empty. But you see that the water color is very different to here. Mm-hmm. Mm-hmm. Side. Mm-hmm. 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 This one. Okay. Mm-hmm. Again, yeah. Yeah. This the. Mm-hmm. No, no. This is not the clock box. This is a clock box. So I give. I'm getting. Okay. So using this water. Mm-hmm. Should I use gasoline? This one. My side is it what time is it now? Yeah? Yeah. Mm-hmm. Mm-hmm.
touching there.
Mm-hmm.
What's in that?
taken over. What does this mean? This. Okay, let me change the position of the container because it's not flat. So, okay, then I can see the texture has changed. Mr. K? Yeah, that's true. ちょっとこう、until settle. Okay. Mm-hmm. 今このワイヤーを Okay, and I'll explain to the Japanese guys that that's we done right now. これ先ほどワイヤーで水をで今こうちょっとこうジェルみたいな感じでやってきてるの。こうジェルというか、まあ、でここの上澄め液だけをこっちに移したんですけど、これ水入ってる状態なんだけど、すごい色が違くてクリアなの。わかりますか？
白くていいよ。
はい。
わかる。普通に。
温度いただく、もう一回していただくんですけど、今日はそうです。今やってます。これがとても、もう私がばっかりなんかすると大変なことになるので。
を外したそこの部分からとかも。
はい、じゃあ両方やってみていいですか？はい。Yes. Yeah. Okay. I don't want to. Let me wash this cylinder. I don't want to. Okay. Okay. Mm-hmm. Mhm. Yes. 今、明け方なんで。Yeah. Oh, oh, sorry. I took some. Let me do it again because, yeah. Yeah. Ah, mhm. Yes. Mm-hmm. It's highly viscosity, yeah. Look at it's not. It has some, yeah, different texture. True. Mm-mm-mm. Okay. Hmm? Mm-hmm. Just a little bit more because it have to be on the line. So let me try. No. Mm-hmm. Ah, okay. Mm-hmm. Mm-hmm. Okay. Yeah, I understand. So it is two. Yeah. Yeah. その次に、そのナノ物質のワイヤーなんで、ワイヤーだけワイヤーが3種入ってます。違う金属の。そこの表面が今色が変わってるので、そういうのが、またアイホースになったりすると、こう、水の微線効果が違う。これまだこう短いかな。この一部しか効率悪く当たらない実況なんで、もっとこう、例えばこれ細いタイプ。この微線は何年ぐらいの強度なの？ギアガーショップで売ってるような、Yeah, okay.
ちょっと、はい。
本当に釘とかの物質したものですか？それ本当に沈めておいたんではダメ。どの銅が Okay. So now, sorry, can you see? Yeah. So now, yeah. Yeah. Mm-hmm. Out of Japanese housewife. Highly trained. Yes. It's getting very melty. Can I say that? Yeah, has a some texture in it. Yeah. Uh, mhm. Okay. Now I move this first cup to us. Okay. So I should mark it. すいません。Number one. Wire. Okay, so it's better to wait for the. すいません。ごめんなさい。Okay, okay. So I fit using the small one, right? Uh,
土の方の結果が出まし
はい。どうですか？
た。さっきの1割減衰したとこからは変わらない。
変わらないですか？両方で出していただいて、
両方
スチロールで。そうですか。わかりました。ありがとうございます。Let me share the result of the copper soil.
送料。もう9万あったんで。そうか。容量が増えたので、薄まった。
でも、何グラム？Okay. So here is the result. 最初のが、そうですよね。11万だったのが、6、7、8、そうですね。8万の製造です。8万のはい。そうですね。先ほどの、これかな？だってさ、散歩してたやつですよね。まさかこれ？違う。どうもありがとうございます。これが、1回目ですね。1回目。はい、ありがとうございます。これの1回目もありますね。ありがとうございます。 Very good. Okay, so here is the result. Mr. Kesha. Oh, yeah. So this is the updated one. It shows almost 25. Originally, 20 cesium 137 was 65,230. Now it became 62,630. So it's reduced almost 3,000 more or less. Yeah. 2,000. Okay. Yeah. You mean that? Yeah, this sample. Yeah. Mm-hmm. Okay. Mm-hmm. Okay. So we are continue. Mm-hmm. Yeah. Mm-hmm. Yes. Yeah, this is from the soil. Yeah. Even that, let me share that the results in the different, in calculating with the mass, it showed the reduction. Can you see? I mean, it's the same sample, but the they recalculated because we are adding the liquid. Yeah, still going down. Yeah. See? So, mm-hmm. 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 Okay. Yeah. That's right. That's true. Okay. Mm-hmm. Yeah. Now I washed it and then clean this up. This is in this. I wish I could see you guys in video. Yeah, I think so. Can you see the differences? This is the second. There's a third. Now the second one actually became a little bit yellowish. So maybe I think the jelly firing is happening in the second one. Mm-hmm. Mm-hmm. ありがとうございました。Oh, but it's very, but I mean, rainy today in Fukushima, unfortunately. It was very bright sunshine yesterday, though, but I was in the garage whole day, so. Oh, yes, I miss sunshine. Yesterday, yeah. My children are in Tokyo with my ex. Waiting. Mommy's back. Yeah. Okay. Okay. So I think there is not enough water. So can I move it from the first container to? Yeah. Yeah. Now it's obviously something happened. Can you see? This is the first. Mm-hmm. Can you see some? Oh, sorry, actually, cup number 1. This is a cup number 1, 2, 3. Mm-hmm. Mm-hmm. Okay. Mm-hmm.
How many trees do we gonna do? It should be in a plastic bag. The instruction on it. How many trees? Oh, sweet. Put in instruction.
Oh, no. I just go. Oh. Yeah, no, not measuring yet. Yeah, here is number 1. But no, I asked them to measure the soil. I mean, for maybe this evening. I think it's the same as like yesterday, like every 2 hours. Do you think? Do you? Yeah? Okay. Ah, okay. Let me ask them. Still ongoing. So let me finish this job.
Yeah, nothing. We
2 to 3, okay. Yeah. Uh-huh. Yeah. Okay. I think I just needed a little bit more, just a few drops. So let me try. But I don't want to take the sediment from the top. Should I repeat the? Yeah. Okay. Mhm. Okay. Yeah. Okay. So it's wire. Hmm. Okay. Now it goes to. But here. was the measurement in seconds. So please wait another almost an hour. Can we take a little break now? Yeah. Okay. Time actually, yes. Yes. CO2 study, it's still on calculation, but it seems like 20% reduction is happen immediately. And no. It's a copper. Yeah. CO2 will be still ongoing. Sorry. So I will get back to the result after the break. The hour. Yes. Thank you. Thank you. Bon appetito. Have a good breakfast. Thank you. Enjoy.